Welcome to Study Loop.
Okay, so here are two circuits. One when the switch S is open, that is for part A of the question, right? Because part A wants us to open the switch and part B of the question wants us to close the switch. So these are two circuits for those two, A and B. Now to find the reading, first let's do A, where we have to find the reading of the voltmeter with the switch S open, right? Now which point is at higher potential, A or B? So to find that out, what we have to do is first find how much with the S open, how much uh, voltage point A has and how much potential point B has, right? So to find that out, well, if the switch S is open, then this becomes just one simple circuit, right? Suppose if current I comes out from the battery, so the 100 ohm resistor gets the same current I. Then as the I moves forward, it does not go this way because the switch is open. Now as it moves forward, it does not go towards the voltmeter because we have assumed that the voltmeters are and the ammeters are all ideal, the battery is ideal, so the I does not go along this way. So all the I goes along A and AB. So the same I would be flowing through this wire as well. So this why I reaches finally to point B and then comes back to 25 volts, right? So let us first find what I should be. Now, to find out what I is, let us use this circuit and write 24. Now, this potential, the battery 25 is connected, the positive terminal of battery 25 is connected to the negative terminal of 15. So they add up, right? So 25 plus 15 on the left hand side. Now on the right hand side, we write the potential drops. Now potential drops is along across the 100 ohm resistor, that is 100 upon into I, and the next one is on the 75 ohm resistor, so 75 into I. So from this, we can get the value of I that is flowing through the circuit. This comes out to be 0.2285 amperes. All right. Now we don't need the current. Actually, we need the potential at A and B, but we can use this value of current to find that out. So as the current I moves to the circuit, the 100 ohm resistor, let us consider that the positive terminal is at 25 volts, right? And the negative terminal at 0 volts. Okay, so as the current moves on, so there will be drop on this 100 ohm resistor, so that drop would be I into R. So the potential would be at this point would be 22.85 volts, right? Now as the current moves forward to point A, so the point A will be at a potential of how much? Because look here, this is a potential here, the potential is 25, there is a drop of 22.85, so this should be 25 minus 22.85, and that is equal to 2.15. So potential at A would be 2.15 volts, right? Now there is a battery here. Now this battery has on this side plus 15, on this side 0, right? So the difference should be 15, and this side, the lower side, should be at higher potential. So the lower side should be, of course, 17.5 volts. So this should be a potential of 17.5 volts, right? Okay, now this 70.5, if you want, this is just for verification, we could just answer by finding that the potential at A is equal to 2.15, but just to verify, I am finding out 11.5 here, sorry, 17.5 here. And on the 75 ohm resistor, the voltage drop would be 75 into 0.2285, and that also should be 17.85. Now this 17.85 drops on 17.5, so V would be at 0 volt. Now you can directly use this 0 here to write that the potential at B would be 0. So you did not figure out what happens in between, because we only need the potential at A and potential at B, right? So, so let's find that out. VAB would be equal to VA minus VB, right? And that will be equal to 2.15 volts, okay? And which is at the higher potential? A is 8, higher potential. So what is the reading? Okay, on the voltmeter, we are done with this. So we are done with part A of the question. Let's move on to part B. Now part B of the question has the switch closed, right? So what can we do? So let us first suppose that now if the switch is closed, let us suppose current I starts from the battery, current I. Now this current I gets divided at point A, and let us suppose that this way the current is I1, and this way here the current is I2. Sorry. I just missed something. There is no current towards the voltmeter, so current divides at this point here. So this way the current is suppose I1, and this way the current is suppose I2. Okay, no current flows towards the voltmeter because the voltmeter has infinite resistance. So what can we do next is use the condition here, use the first loop here, this one. So this loop says that 25 on the LHS, right? There is only one battery, should be equal to 100 times I, and there is no other drops. So this gives me current I would be 0.25 amperes, right? Yeah. Now the other thing that you can do is use this loop and start from 15. So 15 would be equal to, there is a drop on 75 ohm, that is 75 times I1, and since the current is along the loop, it will be positive. Now there is nothing else, right? There is no drop anywhere else, so this gives me the value of I1. Now I1 turns out to be 0.2 ampere. Now we introduced I1 and I2 such that I equals to I1 plus I2. So from the value of I and I1 that we calculated before, we can find the value of I2, which is equal to 0.05 ampere, right? Now the question is asking us, with the as switch as closed, find the reading of the ammeter first. So the reading of the ammeter would be I2, and that would be 0.05 ampere, and the direction of the current would be down, because the assumption that we have made was down, and the I2 value of I2 came out to be positive. If the value of I2 was that we obtained was negative, then we would have to reverse the direction that we previously assumed. So the current will be down. Okay, and what about the reading in the voltmeter? So again, let us find out what are potentials at point A and point B, right? So to begin with that, the potential, again let us suppose that this cell here would be at 25 volt on the positive side and 0 volt on the negative side. Now with this 25 volt there is current I, so there would be a drop of 100 times I, right? So 100 times I is again 25 volt. Whoa, all the potential in the cell drops here, right? So what is the potential, what would be the potential at A? 0. So 0 volt is the potential at A. And again, since this is 0 volt, so B also should be at 0 volt. So B is also at 0 volt. So what potential measures? V across A and B, that is equal to V at A minus B at B. Now both are at 0. This implies VAB is equal to 0. So voltmeter couldn't move. Okay. So this ends the solution to this question. Thank you for watching.